Hi, and welcome to the second last question of this paper. This paper is the 2012 November exam in the Namibian Senior Secondary Certificate, Higher Level Paper 1. Question 11. So we say we have a quadratic function and it has equation y equals px squared plus qx plus r. Okay, so before we get into it, let's just have a look at the basic idea there. So I'm just going to use a, b, and c, because that's the normal way we think about it. And let's see, what does this tell us about a quadratic function? Well, we know if a is positive, we've got a smiley face graph. And if a is negative, we've got a sad face graph. Right, the c value, that's our y-intercept. It's our y-intercept. And the b value tells us something about the shifting of the graph left to right. So we know the x value of the turning point. So if we have a turning point, the x value would be negative b over 2a. And then obviously the y value is when we substitute that back into our equation, we find the y value of the turning point. Okay, so this is quite useful. Then maybe let's just add something to that. We could also have it in this form: y equals a, x plus p squared plus q. Now in this case, the a tells us exactly the same thing. If a is positive, we've got a smiley face. If a is negative, we've got a sad face graph. And then from here, we don't know what the y-intercept is. We can't read that off, but we can read off our turning point. So our turning point or stationary point is this. The opposite of that, so negative p, and then this value here, q. That's our turning point. Okay, so that is some of the information we can use to sketch graphs or to know what graphs look like for parabolas. And the method we use to get from this one to this one is called completing the square. Alright, let's get into the questions. Question A1. Sketch a possible graph of the function if p is less than 0. Okay, so the number in front of the x squared is negative. What does the graph look like? Looks like this, right? If the a value is negative. So we can just draw our Cartesian plane and then sketch any sad face graph. That's it. You could have sketched it there, you could have sketched it here, you could have sketched it here, doesn't matter, right? Any sad face graph will do. The second part of question A, sketch the graph of the function in the case where p is 1 and q and r are both 0. Okay, so let's see what happens if we do that. So if p is 1, q is 0, and r is 0. That just leaves us with 1 times x squared is x squared plus 0 plus 0. So just y equals x squared. Now we see it's a smiley face graph, and then we can sketch it from there. Okay, let's draw a Cartesian plane with our y-axis and our x-axis, and y equals x squared. Now to find the x-intercepts and y-intercepts, we'll make one of them 0. So to find the x-intercepts, for instance, then we must say y equals 0. Okay, if we apply that, we get 0 equals x squared. Take the square root of both sides. So then square root of 0 is 0, so 0 equals x. So the x-intercept is right there. And obviously we can see that's the y-intercept as well then, because it's already on the y-axis. But just to be sure, let's say y-intercept, that's when we make x 0. Okay, so that means we've got y equals 0 squared. And what is 0 squared? That's 0. So we see that is our value. And then we know it's a smiley face graph. So all we need to do is draw a smiley face graph that has a turning point right at the origin. And there is our graph. Perfectly done. And it's always just good to label your points. So just put down 0, 0. That's the coordinate right there. Great. Then question B. Question B, the first part. Express 2x squared minus 3x minus 4 in the form of this. That must look familiar to you. Right at the top here, we see we go from ax squared plus bx plus c, which looks like this, into the form a times x plus p squared plus q, which looks like this. So that's completing the square. Now let's look at a bit of how to complete the square. The first thing, I'm just going to rewrite the question here, and then we'll work it from there. So 2x squared minus 3x minus 4. So first thing we need to make sure of that the a value, the number in front of the x squared, that must be 1 before we can continue. At the moment it's 2, so what we can do is we can factor out that 2. And what's left? Well, what's left is x squared minus, what's 3 divided by 2? Well, we just write 3 over 2, and then 4 divided by 2 is 2. Okay, now that we've factored out that part, the next step is to rewrite the first two terms. So I'm going to do x squared minus 3 over 2x. Then what we do is sort of the interesting part. Then we add and subtract something, because we can't change the value, so that's why we add and subtract it. And what we add and subtract is b over 2 squared, right? And then obviously we have to add the negative 2 at the end still. So what is b over 2? Well, b is the value in front of the x. So it's that value. 3 over 2 divided by 2 is 3 over 4. And just to show you, to make sure that it's true, I mean, you can type that in your calculator. If you just type in your calculator 3 over 2, that should give you 3/4, right? 0.75. Perfect. And your calculators can probably give you nice fractions, so you don't have to do the decimals. Alright, so once we get there, now this is pretty cool. The reason why we did that is so that this whole part here, the first three terms, they now become a perfect square, hence the name completing the square. Okay, so that's going to be a perfect square, something square. And what goes in the bracket? Well, it's the x, it's a sign next to the x, and it's the thing inside the bracket. Just like that. And you can test it for yourself. If you multiply this thing by itself, if you square it, you should get that answer back. If you do, then you've done it right. Right, and this we can just work out. You can type that in the calculator. I'm just going to do it step by step. So minus 3 squared is 9, 4 squared is 16, and then minus 2. Now 2, I'm just for common denominator, I'm just going to say 2 is the same as 32 over 16. Alright, let's simplify a little bit. So we've still got our x minus 3/4 squared, then minus 9 minus 32 is minus 41 over 16. And then as a final step here, we have to multiply the 2 into the big bracket. So into there, which gives us 2x minus 3 over 4 squared, and then into that part, which is, if you multiply that by 2, you get negative 41 over 8. And that's done. That is our answer. Perfect. That was the first part of B. And then the second part, B2, we're asked, hence or otherwise, find the coordinates of the stationary point of this curve. Okay, so if they say hence, we know we must use the previous answer. But they say hence or otherwise, so now we can use the previous answer, or we can do any other method we like. Okay, so let's do both methods, or not both, two of the many. One method that we can use is to use the previous answer. So if we look back here in the blue part, we said if we have it in this form, we can just read off the turning point, right, from here. So the turning point will have an x value, which is the opposite sign of this part, and the y value of the turning point is just exactly what we add or subtract there at the end. Okay, so we can read that off. So our turning point is this thing with the opposite sign, so it'll be positive 3/4, and the y value will just be exactly this, negative 41 over 8. Done. Now if we didn't want to use this, or if you didn't know you could read off the turning point from here, we can use what we said over here. We said the turning point has the x value of negative b over 2a. Okay, so our turning point has the x value of negative b over 2a. I'm just going to rewrite this equation here. Y equals, what was that again? 2x squared minus 3x minus 4. Y equals 2x squared minus 3x minus 4. Okay, so the turning point has an x value of negative the b value over 2 times the a value. Okay, and then a y value where we substitute that point in. Alright, so the x value is negative 3, which is positive 3, and 2 times 2 is 4. And then we substitute that back into our equation to find the y value. Okay, substituting it back in, we get y equals 2 times 3/4 squared minus 3 times 3/4 minus 4. Okay, so 3 over 4 squared gives us 9 over 16 times 2 is 9 over 8. Okay, minus 3 times 3 is 9 over 4 minus 4. Let's get a common denominator, which will be 8 in this case. That 9 is fine. This 9 has to be multiplied by 2, and this 4 has to be multiplied by 8. Okay, so 9 minus 8 is negative 9. Negative 9 minus 32 is negative 41 over 8. So we see we get the same y value. So our turning point, we use this method, is 3 over 4 for the x, and then negative 41 over 8 for the y value. And we see that's exactly the same as from this method. Obviously this one is much easier, or much quicker, let's rather say that, if we already had done the completing the square part. Alright, so that is it for this video. I think there's one more to go, and that'll be the end of this paper. Yep, that's it. Just one more question to go, although this one looks like it has quite a few marks involved. Might be quite an involved question. I'll see you shortly for that one.